Hi everyone, this is David at Everlasting Media. I want to show you this wireframe mesh basket really quick. So this is kind of a basket pencil holder. It looks a lot like Voronoi. It's not Voronoi, and I'll show you how to make that at some point. It's a little bit more advanced. For now, I just want you guys to see this really important message from my awesome YouTube channel that needs your support. In any case, so look at this really awesome little mesh basket that we have here. Now, this could be used for a lot of things. This could be a waste basket, pencil holder, pen holder, great place to, if you have knives, you could certainly put them in this. But otherwise, the concept of creating this kind of mesh is pretty simple. It's not as hard as you would think, but I'm going to go over a few things to introduce you to the modifier stack and get you more comfortable with that. And I'm also going to show you some of the fairly quintessential shortcuts for using Blender effectively. So to get started, let's go ahead and open I'll leave this open actually. And I'm going to use, before we even get started with that, let's talk about Blender Launcher. So this is Blender Launcher, and whenever you're learning from tutorials on Blender, one of the more frustrating things you're going to run into is that the person giving the instruction is going to be using a version of Blender that you don't have. This solves that problem. Stop using Blender on Steam. I know you want to use it. The thing is even though you can install earlier versions, I think you can only install one version at a time. Even if you can install multiple versions of Blender for Steam, you might not want to. It's actually a little bit more difficult than doing this. This is easy mode for having multiple versions installed. Blender is fairly lightweight. I think it only consumes maybe 100 megabytes now with current versions. Earlier versions probably have a lot less overhead. But this Blender Launcher, it was broken previously. It's fixed now. You can actually see it has many versions available for download. I recommend having the most current version, 4.0.2. This is the latest stable version. Maybe having an LTS version. I believe 3.3.11 is a great version. And then you're probably going to want a really, really old version. I think 3.0 would probably be a great idea to have on hand, because you have some of those really old tutorials that have a similar process, a similar flow to current Blender, but they teach you the method, the process, and the basics behind it. And you don't want to get hung up on learning the software over learning the technique and approach. So if that gets in the way of what we're working on, just know that we're using Blender 4.0.2, which is not the latest version, but it is one of the more stable recent versions of Blender, and it's a great version. I think you should download it and use it. Okay, so it's what we're using for this lesson today. Let's go ahead and get started here. I'm going to go ahead, right click, and then I'm going to go back to my pencil holder. I'll go ahead and open that up. Okay, so you can see we've got the pencil holder here. The first thing I'm going to do is I'm going to go up here to our overlays and our gizmos and turn both of these on. Then I'm going to get out of my camera mode. Now, if you ever want to move the camera around with the viewport, you can do that with this setting right here. If you hit 0, this shows you the rendered camera, right? So we have a camera in the scene. As long as you have a camera in the scene, and it's your primary camera, then you can snap your camera to your view using camera to view right here in the view block, and it will move around. So you can actually rotate around your object and see what it's going to look like in rendered view, what's going to be in frame from different angles. And it's also a great way of actually animating the camera, because you can keyframe in animation mode and move the camera around just like this and get the same effect. Okay, so for now, we can go ahead, turn this off, get out of camera view. We don't need that for now. And please like and subscribe to the channel. Oh man, I stuttered saying that. See, I've got a lot of work to do, a lot of learning. But if you want to see my content improve, please like and subscribe. Make sure you click the notification bell so you can be notified whenever new content drops. Okay, in the meantime, we're going to move our camera out of the way. We don't really need that here. I'm going to scroll out, move it over. And then while we're messing around, I'm going to turn on the screencast keys. This is a built-in plugin that you can use. Actually, I think it's not a built-in plugin. I think it's a third party, but still, works great. Okay, so now I can hide this. I can hide this. And I can turn on box select mode by hitting W. Okay, so if you want to hide something, you can just hit H, and it will hide literally anything. And if you hit Alt-H, it will unhide everything you just hit. Okay, but you don't need to do that. I'll Control-Z, hide everything again. We have these lights. We can go ahead and move those out of the way. Boom. They're moving on local axis, but if I put it on global, it's right here, and they'll both move together. So their local axis just splits them apart. I prefer using that. And then we can get our cursor back to center. This is just some basic setup. Anytime you're working on a new project or anytime you're coming back to an old project, you may want to just reorient yourself. Okay, selection to cursor. All right, so now we're all centered up. Let's go ahead and get zoomed in. If you hit period and you have an object selected, it will focus that object and move your viewport camera so your object is centered and you can orbit around it easily. It looks really nice whenever you orbit around this. It's got a nice spiral effect to it. Okay, so the next thing we want to talk about, by the way, if I'm going too fast, let me know in the comments. Let me know what you think of the content of this video. If there's something I can do to improve, please tell me. Okay, so we're going to drop this down right here. This little drop down is for our viewport shading. And if we're in a solid mode, viewport shading drop down has some really interesting options. This is one of my favorites. It allows us to see how light is going to hit our object and the flow and how smooth our surfaces are. This one is it's got really smooth surfaces. We like that a lot. And we can also use one of the other lighter or darker modes. This is one of my favorites. It allows you to see surface defects really easily, and ours does not appear to have any surface defects. Don't worry, it's about to. Okay, so we're going to go ahead and use this mode, and we're going to get started with getting rid of unnecessary geometry that we need for this. The first thing that we're going to do is we're going to drop down, click on Item in the Item tab. We're going to look at the scale of our object. Right now, the scale of our object is 0.065. Okay, this is going to be important. I'm going to bring this up later, so we're going to leave that as it is. In the meantime, we're going to go into edit mode, go into face select mode. We'll select the bottom face on the inside. Now you can select the outside too, but for the purposes of this tutorial, you may want to just stick with the inside. I'm not sure how it's going to look with the modifiers applied on the outside. Okay, so Control plus or minus allow you to control how many faces or edges or vertexes you have selected, and it always starts with the first one you select, so it could be this one. It will expand from there. So we'll select the bottom one, and we're going to go to the very last edge loop right here. Okay, now if we hit X, we can delete those faces. And by the way, you can also delete vertexes, edges. Only faces will leave all of the edges there, and you can convert those into curves and then do all kinds of wacky stuff. I'll show you guys how to use that stuff in later tutorials. Dissolving vertexes, dissolving edges just combines all the nearby faces or edges or vertexes into one. So if you have two vertexes on an edge and you don't know why they're there, you can combine them into a single vertex or make them disappear entirely. Okay, so for this, we're going to delete these faces. And now we just have a nice spiral shell. Now, this doesn't have any substance to it, so if you tried to 3D print this, you probably wouldn't get very far. So the next step that we're going to do is we're going to come over here into the modifier stack. Now, we have our subdivision. We can probably just turn that on to simple subdivision because we're going to be subdividing and making things smoothing in layer. Our simple deform can be left as is. This subdivision can be left as is. And now what we can do is we can add a wireframe. Well, that looks really interesting, doesn't it? Look at the flow of these edges, though. You notice how it's rotation of like a couple of degrees and then stack another one, rotation of another degree, a couple of degrees, and stack another one. So that's really interesting. And then notice how our bottom has a particular geometry to it. Let's go ahead and correct that now. Let's select face mode, select our bottom face, delete it. Now what we can do, if you remember how to edge select a edge loop, you can go into edge mode, hold Alt, click, and you can select that whole edge loop. Now if we Control F, we can come over here to grid fill. Grid fill looks really cool. It adds quads to fill up an even number of vertexes with faces. So if we step this over, and I believe 3 is probably going to be the right one, and then if we offset 2, we get this really nice grid fill in. And if we tab back into object mode, we can see it has done a really good job of filling that space in. Now, you could 3D print this totally. this would look interesting for sure. The problem is you'll start to notice this. 20 millimeters, do you think that looks 20 millimeters thick? Not if our actual size of our object is anything close to what it looks like here, 120 millimeters. But look at the scale. So you need to multiply this until this becomes 1, right? That's the actual scale that our modifiers think that it's at. So if we apply our scale, Control A, scale, you can see it still thinks that we're trying to push 20 millimeters. It's probably closer to 1.2 millimeters. There we go. Now that looks right. 1.2 millimeters, that would be about the right size for it. But if you notice along the top here, it's actually open. We don't really want that. So if we turn on boundary, it will fill the end cap of our mesh with an actual piece of wireframe and cap it off for us. It looks really nice that way. It looks way better that way. We'll go ahead and leave that. And 1.2 millimeters is based off of having a 0.4 millimeter nozzle. You may want to increase or decrease this depending on how many walls you want to have. Although your slicer will try to divide however thick the wall is by the number of paths that you set and then infill the rest. But this is just, it's not magic numbers, but it's just good practice to have a shell thickness or a wall thickness that is a multiple of your nozzle diameter. It's just a good idea. You'll probably see it in practice as you're 3D printing more and using software like Blender. Okay, so there are a few defects. I noticed one down here. I noticed a couple on the corners, but when we add another subdivision, let's duplicate this one. I can bring it down. You'll notice that some of our issues go away. Okay, so some of these corner issues just kind of disappear. And we can also do a decimate and combine some things based off of their distance. But speaking of decimation, let's say we don't want the flow of these edges, of these, you know what I'm gonna do? I'm gonna turn this off for now. So let's say we don't want the flow of our faces here, our loops, to go straight around and then stack. Let's say we actually want them to spiral up. We can do that. We add a decimate modifier and we drag it up before the wireframe. I think we could actually move it before the subdivision. I'm not sure it matters. Let's leave it right here. Okay, so we unsubdivide and then we step this up to 1. You know what? I think it actually does matter, but this looks cool too. That has a really interesting pattern. And if we turn this back on, with our subdivision back on and stepped up a little bit, you get a really neat effect, kind of a build-up effect. Now, we can move our decimate to before our simple deform, may not change much. Move it after. We can try even moving it after the subdivision. This is effectively what we had in the other Blender instance. You can see with the whole pattern. Go back to solid mode. And we'll switch our matte cap to that. And you can see it's almost identical, not quite, but close. Now, if we look at this stack, subdivision, simple deform, subdivision, decimate. Same thing. Although I think this was Catmull Clark. And that's what made up the difference. So it's just slight little difference changes. You don't have to do much to get your effects. Yeah, that looks pretty good. So now that we've done that and we've seen the difference between moving our decimate around, we can actually move our decimate for this again. So at this point in the tutorial, my microphone died. I apologize at this stage. I expected that my microphone would have lasted longer since the video was only 20 minutes, 25 minutes. Unfortunately, it ended up taking several takes, several hours of work to actually get the recordings out. So I apologize for that in advance, but I'll do my best to make sure you have a pleasant experience. Okay, so let's keep going. Okay, so I'm going to go ahead and explain a little bit about what's going on screen here. So I do a little bit of showing the mesh, and I explain a little bit about the modifier order and generally how modifiers will affect the flow of geometry on your mesh, how subdividing your mesh can increase the geometry and give more for your modifiers to work with. But I think I was showing you generally how you can make a tighter mesh on the base. Now, sometimes if you have a wider mesh, it's better because you have more vertical layers that can stack and less overhangs that your printer has to deal with. And you also should be reminded that your printer will end up making quite a bit of noise when it's going back and forth in all these holes. It tends to be a little hard on printers, especially if you try to print these types of things fast. It's normally better to print them at, stock prusa speeds or slower even. And then you get better overhangs. You might want to work on your cooling. This is actually kind of a prototype benchy in a way because it has so many overhangs and so many corners, lots of little gaps to fill. But you might notice that, and I'll show you in the slicer in a moment, you might notice that some of these overhangs are hard to deal with without using supports. This is a print that I probably would recommend using a soluble support with. So I turned on the subsurface modifier a second ago, and anytime that you increase your subsurface divisions, you're going to end up having a lot more mesh. Right now, the mesh is somewhere around 1 million vertices. That's a lot. That is a lot of poly to deal with. So I'm actually exporting an STL right now. And I just wanted to show you that it doesn't matter that's 1 million vertices. You can still export the mesh. I'm going to turn on selection only. And I'm also going to make sure that modifiers are applied. The scale there is set to 1. You can change that if you need to. Maybe you model in a higher resolution because the modifiers behave better in Blender. And then you can have it. So if you know that you need a 120 millimeter wide base, you can build it in 240 millimeters and then just export it as half scale, and it should do what it needs to do. So we're going to go ahead and add that base. And I'm just showing you that it actually adds, it asks you if you want to convert the units from meters to millimeters, which of course, yes, because Blender doesn't have a way to export, spelling out that it needs millimeters instead of meters. Okay, so now it's imported in millimeter units, and it has a setting of 0.2 millimeter layer heights with a 0.4 millimeter nozzle. And if I go ahead and slice it, you can see that it's going to give us some warnings about unsupported geometry, overhangs, whatnot. And I'm just showing you here that the walls, there's only 2 walls, so it's going to do inner and outer. But if you want more, you can change that in the settings. The infill is set to, it looks like it's set to like 10 or 15% there. Anytime you have a low amount of infill in a model like this, it's probably a bad idea. In fact, with a model with this many holes in it with thin walls, you might want to just do 100% infill. It's not really going to change how much time it takes to print, but it will print it solid and it'll be stronger for you. I'm pointing out the overhangs here. All these overhangs could end up looking droopy, but if you have a nice filament and you have a well-tuned printer that has active cooling, working well with the nozzle, especially if it's even cooling, you'll end up with a good result, I believe. I've had really good results with these types of vases, and even if they do have some slight droopy overhangs and they're not perfect, most people will still really like what you did here. It'll still be an impressive print. Now, you can clean this up. There are ways to clean this up, and I'm talking about making future tutorials. I do plan on showing you how to use booleans and how to combine meshes to make just cleaner overall meshes, things that are easier to print. Not necessarily easier to print as in bad, easier to print as in it doesn't need to be this hard, work smarter, not harder type of thing. And I'm just showing you the density of the mesh and generally how close the layer lines are together. Now those corners, the 4 corners in this twist, I'm a little worried that there's just too much detail there. We can work on ways to create modifications, either procedurally or just to change our mesh so we don't have so many holes, because there are quite a few that just seem unnecessary. In any case, I go ahead and I slice it again with more walls and better infill, and you can see that it doesn't really matter in terms of printing because you're not going to print this with supports. Supports would ruin this print. You'd destroy this print trying to put supports on it, unless they were soluble. If you have soluble supports, then you're home free and you can print this thing perfect ridges everywhere and you have no worries. But that's not the case for most people. Soluble supports, very expensive material, and not a very convenient material to print. You need huge purge volumes on most printers because the type of supports is usually PVA filament for a lot of people, and PVA filament is notoriously bad for nozzle contamination and ruining prints. So we should do things later on down the road to limit the amount of geometry that is being fed that needs those types of supports or support at all. And the base is one of those areas that we can strip away a lot of that redundant extra garbage geometry. So what I decided to do here on the whim, on a fly, because we've pretty much accomplished the mission of this tutorial already, is I go back a couple of steps and I simplify my mesh a little bit, because I was just showing you a tighter mesh. That wasn't really the target. This is more the target geometry that we were going for. And I think I'm actually telling you that right there, compared to the geometry that we actually sliced so far. So I go ahead and start working on creating geometry that is more akin to what you would want to print. And this is probably it right here. This is what I demonstrated in the tweet that everybody saw. I think I got 18 or 20 likes or something. It's really nice. People seem to be very receptive to my printing and Blender ideas. I really appreciate that. So I think I'm talking about scale here, and I'm just going over how you can manipulate the scale a little bit and get different results with your modifiers. But I make the mistake of deleting a couple of modifiers on the main mesh, and actually decide to reverse that. And before deleting those modifiers with their settings, I go ahead and duplicate this mesh. So you can duplicate the mesh by holding Shift and hitting D. So now I've already created a mesh, but the thing is I don't want this pattern on the inside and the outside. Now you can do that. You can have a pattern on the inside and the outside, and it gets rid of your bridging problem almost completely. But for me, I want to go ahead and just have the pattern, the wireframe pattern, on the outside, and I want to have it solid on the inside. So I figure out what the width of the wireframe mesh is, so it's 1.2, and I just have it basically. And there you go. And you could, of course, increase that if you want to. You can increase it to a whole millimeter if you wanted to make it thick and strong, and just have that pattern on the outside. That's a really neat way of tricking, or at least creating the illusion of having hard surface modeled features onto your 3D printed bases. And you could probably replicate this anywhere, to be honest. So I go ahead and move this off the bed. Of course, it's not cooperating because I don't know what the hell I'm doing. There, go ahead and drag it off the bed. Then I have to do it again because it updated. Import the new mesh, the new STL file, instead of renaming it. Apparently I named it wrong. Again, it asks me if I want to convert units. So now the imported mesh, I want to make sure that I have the right settings for this as well. But when you slice this, you'll already see that it's not complaining as much about overhangs. Now you still do have some overhangs, just because of the nature of this print, because it's twisted like this, you will have some, but it's going to be better overall, I think. Easier to print anyway, and it's actually solid, so if you wanted to, you could probably even print this to be watertight, to make it an actual vase, something that can actually hold something. But at the very least, it will be more durable, it will have more internal support structure. And I think if I move that off the bed, I can show you that to greater detail if I actually did that and then sliced it and showed you the other overhangs and everything else. There we go. The slicer always does something right at the end here. It does a bunch of tidying up. As you can see, most of our overhangs are confined to the lower area where I have all that packed geometry and then the base. Now, a lot of that is going to sag and stay stuck to the bed, but you can see there that that pattern doesn't need to exist on the bottom, and we could actually delete the pattern from the bottom just by deleting that face on the wireframe and leaving the rest of the mesh intact. We could even hold Control, select a little bit more of the mesh with ++, and delete those bottom bevels, and then just extrude that, those 2 or 3 or 4 millimeters straight down to the bed plate. And then maybe bevel them a little bit, because typically bevels that are like 45-degree bevels, they don't have too many issues being printed. Unless your printer just really struggles with overhangs and bridging, then it probably would have an issue. But if you don't have those issues, if you don't have those struggles, even this print with these overhangs might be easy to print, especially on like a Bamboo Lab or K1. This is David at Everlasting Media, and this was my tutorial on how to create a Wiremesh Vase. If there's anything I can do to improve my content, please let me know. You can't hurt my feelings, you can only hurt my time. If there's any content you would like to see, please give me a shout out in the comments or hit me up on Twitter, emediatweets. Please subscribe, please follow, and please hit the notification bell. Thank you guys so much, and take care.